Welcome, friends, and I'm in space, roaming around in my imaginary spaceship, and I'm right now speaking to you from my command center live across all social media platforms. And today, I would like to talk about the new findings that James Webb, the latest shining telescope, can do and how it can help us identify aliens. It's an important discussion. So let's understand what are the capabilities of James Webb. Well, James Webb, as I said, is a very remarkable piece of machinery and it is so different from usual telescopes. It looks like a radar, but it is actually a telescope. And unlike the other telescopes, which looks like a tube and you can see through all these, but James Webb is a special telescope which sees only in the infrared spectrum, and that too when we talk about infrared, in the extreme infrared side of the spectrum, so that it can see something which is not visible to humans. And then it also carry many onboard laboratories, analysis based instruments, so that it can actually analyze the light locally while it is getting the light, and then after performing this analysis, create those into nice pictures and send it across to earth, to earthlings, for basically further analysis and identifying what it has seen. And because it looks into the infrared spectrum, it has the ability to penetrate through the clouds and also look at very very minute details about the object it is focused on. And that is the exact capability that mankind can leverage of James Webb, because it's very very precise and it looks into the infrared. It does not look anything in the visible light, it does not look anything in ultraviolet. It looks in a very very narrow band of infrared, which is on the far side of infrared, so it can see many things which human eye cannot see. So that is the capability that scientists want to exploit, or rather use, to understand the nearby star system. And so far we have actually identified, without the James Webb, we have identified about 5,000 exoplanets. So exoplanets are the planets which exist outside the solar system around other stars. So we have actually, in the near vicinity nearby, we have identified 5,000 planets, and now using James Webb telescope we can examine very minutely the characteristics of these exoplanets. But before we start talking about that, I would like to tell you that the highest number of stars in our universe or in our galaxy are the red dwarf stars. What are the red dwarfs? These are also called M class stars, which are very very small, almost like 15 to 20, 10 to 20% of the sun's size. So these are very small stars, almost 20 times smaller than sun, or up to the 10 times smaller than sun. They emit very little amount of light and very little amount of heat as compared to sun. Although you should not be mistaken, they are quite hot, because they are star after all, they are burning and there is a fusion reaction going on. Then the other big difference between red dwarf and the yellow star, which is our sun, is that in our sun most of the reaction happen in the core, which is in the central part of the star, whereas in the case of red dwarf, the fusion reaction, that means hydrogen combining to form helium, is happening across the star, everywhere. So and because of that, because there's less pressure on the star, the fuel, or rather hydrogen gas, which consists or which act as a fuel in a star, will burn very slowly. That means the reaction is rather slow as compared to our sun. So red dwarf is first of all there are more in numbers. Almost 80% stars that we see are red dwarf stars. Second, they live longer, at least 10 times longer than the sun. So if sun life, as per our estimate, is about 10 billion years, the red dwarf on an average can live over 100 billion years. So our Earth is about 4.5 billion years, and I think in a billion year from now, it will not be livable. So within last few billion years or few million years, the life has evolved. For most of the time, Earth was barren. The conditions for life to evolve wasn't there. So considering this fact that life evolved in a very short period of time, because on Earth we get a very short window for life to evolve, thrive, and probably perish after a few million years or few 100-500 million years, because after a billion year, Earth will not be livable. It will probably become like Venus because of the runaway greenhouse effect, which is going to happen in future sometime. So comparing the yellow star and the red dwarf star, the red dwarf star, if there is life or there is a livable planet around a red dwarf, there is better chance for life to evolve, because the star has a very long life, and because of that there are no sudden surprises in a red dwarf system. And if there is a planet which has life, the planet will get longer time to evolve into much more complex and very advanced civilization, just in case if there is an intelligent life form on a red dwarf star system. So that is the first thing that I wanted to talk about, and how James Webb can help us identify. Well, I think that James Webb is looking into the infrared spectrum. So because of that, it can actually see the heat. So even if there is a heat of a caveman on some planet creating a fire, the James Webb is so sensitive it can actually see. So if there are 5,000 planets that we have identified even before the James Webb was launched into the space, we can now examine which are these planets are livable. And since most of these stars around sun are red dwarf, so finding a livable planet around a red dwarf with life and with habitable conditions is most likely, because sun type stars are exceptions. They are not found every day, whereas red dwarfs are found everywhere, and there are planets which can be seen around a red dwarf. And some of these planets, we need to now use James Webb to study these planets so that we can identify where there is a habitable environment on those planets, and if there is some sort of life form. Now the second point I want to draw is that I think we are convinced that if we have to find life, or if we ever be able to locate life outside the Earth, that will be in a red dwarf system, because red dwarfs are very stable systems. Second is, we will probably not find Earth type planet, simply because Earth type planet is smaller, and because it's a small planet, in other star system you usually get something what is called super Earth. Super Earth is at least twice the size of Earth. That means it has twice the amount of gravity, and it will also have twice the amount of everything else, all the material. So most of the planet that we see going around all stars, including red dwarfs, are super Earth, at least twice the size of Earth, up to 10 times the size of Earth. And we do not see Earth type planet. I mean, we see one or two, but again, Earth type planets are exception. What we see around in other solar systems are the super Earth. That means much bigger Earth with much thicker atmosphere, higher gravity, and more material, and also a stable star system which will allow life to basically evolve by permutation and combination, and that's how the life evolved. We know that. At the same time, we know all these things, that super Earth are better suited for life to evolve and flourish and also become intelligent and probably become more capable civilization. So we need to see these signs when we look around using James Webb Space Telescope. Now, here also we need to be very cautious because there are different types of environment on different types of planets. One of the type of planet could be the water world. And when we talk about water world, that means if there is a lot of water, the water will evaporate and quickly this extra steam which is generated in the atmosphere will lead to a runaway greenhouse effect. So even if we see a water world around a red dwarf on a giant planet or a super Earth planet, the chances are that kind of planet will not be able to sustain life for very long time because all the steam will boil away and then create more greenhouse type of effect, which is going to make it very warm and not suitable for life. At the same time, if you look at the Earth itself, the oxygen was there was no oxygen. Actually, oxygen started after the photosynthesis process started, because photosynthesis was used by plants and some of these algae to convert the eatable carbon monoxide, carbon dioxide, and take the carbon. So that carbon is a food basically for the living organisms and plants, and release the oxygen. So gradually, once the life evolved, gradually oxygen was built up in the atmosphere of Earth. Similarly, if enough time is given for these plants and the other species to take to basically look at the photosynthesis, then only after millions of years the planet will become habitable for humans. So that is why search for life most likely will be on a red dwarf star system, and specifically a super Earth type system, which will have thicker atmosphere. And therefore, once you have a thicker atmosphere, the permutation combination can also happen in the atmosphere, unlike Earth, where most of the life evolved in oceans and then crawled on the continents. So on a super Earth, the life can evolve even in the air. So life evolution, a certain type of life can evolve completely in atmosphere, because atmosphere is so thick it can support life being floating around. So all their life to death, there are certain life form which can exist on super Earth, which will not there was no need for them to come down on the ground. So these are certain differences that we can expect, and therefore the closest star system called Proxima Centauri, that is hardly 4.2 light years away. I think that has about 5 stars. It's a red dwarf system, and there are 1 or 2 planets which are in habitable zone. That means since these are super Earth planets, and we know that these are super Earth planets, and they are in the habitable zone. So if they are in habitable zone, they are getting the right amount of heat to melt water on the surface of these planets. And since they are super Earth, chances are there would be continent type structure on the surface, just like Earth we have on Earth. Thicker atmosphere, continents, water in liquid form. So what we need to do is these are the right candidate, just closest neighbor in the neighborhood. We have to basically point JWST on these planets and identify if somebody is lighting a matchstick, because JWST can is so sensitive. It can see the signs of not only signs of intelligent activity on the surface of the planet, but also see the heat signature and the composition of the atmosphere very easily. So these are certain things which are capable. These are the capabilities of James Webb, and that is why it is a wow moment for all of us, where James Webb is out there, and I think it should start looking at these planets specifically, so that we know that there are other species living around nearby, in the nearby space-time around Earth, and we are not probably alone. And that is the biggest question that James Webb can help us answer. And that is why I am so excited, and I thought about bringing this short live stream for you from my spaceship directly into your social media. So what do you think? Do you have any opinion about this subject? Do you think James Webb will be able to tell us if there are aliens? And if these aliens are there, are they more advanced than humans? If they are more advanced, are they coming to meet us? I think these are certain vital questions that we need to answer, and James Webb will help us find these answers. So I will actually look towards your comments, and thanks for watching, and I will catch you again tomorrow. Please take care.